Welcome to this lesson on specific heat capacity. Why do you need to wear oven mitts to take things out of the oven? To protect your hands. The air in the oven doesn't hurt your wrists. Different substances hold on to heat in different ways. So just because you have equal quantities, let's say, of copper and magnesium, do you think that they would be able to hold on to heat in the exact same way? Would their temperatures each rise at the same rate? The answer is no. They are different metals with different atomic structures, so their physical properties allow them to hold on to different amounts of heat. There is a pretty crazy definition of specific heat out there, but the way I like to describe it is just a measure of how well substances hold on to the heat that they gain. So if you think back to the oven situation, the metal inside of the oven, like this cookie sheet or the metal racks of the oven, hold on to their heat a lot more than the air inside the oven. Substances that have high specific heat values take a long time to heat up, a long time to cool down, and they hold on to their heat very, very well. We often say that water has a high specific heat and metals have low specific heats, meaning they heat up quickly, but they also cool down quickly. To figure out exactly how much heat energy it's taking to change the temperature of a substance, we will use the equation Q equals mc delta T. Q stands for the heat energy measured in joules. M is the mass measured in grams. C is that specific heat capacity, and the units for that are joules per gram Celsius or joules per gram Kelvin. The change in temperature, we can do it in Celsius or Kelvin. Most often we're going to use Celsius because we're going to be more or less using this in a lab setting, and our thermometers measure in Celsius. Delta T really just means change in temperature. That's what delta stands for in equations. So in that case, it would be the final temperature of the sample minus the initial temperature of the sample. If you wanted to find out how much you grew in the last year, you would take your height now and subtract the height you were this time last year, the final minus the initial, and that'll tell you how much you've grown. In this case, delta T is going to be the final temperature minus the initial temperature, and that is going to give us the overall change in temperature. Occasionally, you can use calories to measure the specific heat of water. The specific heat of water in calories is 1 calorie per gram Celsius, meaning it's 1 calorie of energy to heat 1 gram of water 1 degree Celsius. We often in chemistry use joules. We have 4.18 joules of energy are needed to raise the temperature of 1 gram of water 1 degree Celsius. You'll see how this plays out in the calorimetry lesson, in the heating and cooling curves lesson, and more specifically in the calorimetry lab that I do where I measure the heat of fusion of ice. If you have any questions, please leave them in the comment section below the video. Subscribe so you don't miss the next lesson, and I will see you there. Bye.